Hi friends, this is Rashekar, a GATE faculty for electrical machines. Today in this video, we are going to discuss about short circuit test of the transformer. Let's see short circuited test. Let's see, for example, this is my transformer. This is my transformer. I am conducting test which is short circuit test. Short circuit test, nothing but here short circuited. The secondary winding is short circuited. Secondary winding is short circuited, and here the current is taken as ISC, for example. And this is my primary winding. This is my primary winding. And here current I, and to know the voltage V, to know the voltage V, and to know the power wattmeter, to know the power wattmeter, and here the supply voltage, and here the supply voltage. This wattmeter is WSC, it is called WSC. And of course here the current is I. Now see, this is the short circuit test circuitry. First of all, what are the aims? Why we are going to conduct this test? What are the aims? Up to now in open circuit test we just calculated no load losses. But now we can calculate copper losses also from this test. So simply to find the copper losses, to find the copper losses is the first one, and also no load parameters completed. Now to find load parameters is the another one, and next to find short circuit impedance and short circuit current, and next to find voltage regulation, These are the aims of my short circuit test. Are you okay? Next, specifications. What is the current? Here the current drawn by the transformer is rated current. Up to rated current, we have to take up to rated current. Sir, what about voltage? The voltage is up to rated current. Nothing but we are starting at 0 voltage. Slightly increasing this voltage, slowly, gradually increasing this voltage by analyzing this ammeter. By seeing this ammeter, up to rated current, we have to increase the voltage. Generally, at 8 to 10% of rated voltage, we can get the rated current here. So the voltage applied is 8 to 10% of rated voltage. What about wattmeter? Here we have to use UPF wattmeter. UPF wattmeter is used. Now you have one doubt. Sir, if rated voltage applied to the transformer, if rated voltage applied, then what happens, sir? If rated voltage applied here, then what happens? If rated voltage applied here, at 10% of voltage, we got the rated current. For example, if you applied 100% of voltage, then large currents flows in the winding. Those large currents are called steady short circuit currents. Those currents are called steady short circuit currents. These currents may damage the transformer. These currents may damage the transformer. These currents are called steady short circuit currents. Steady short circuit currents. Remember this. Are you okay? Right? Next one. Next one. So, what are the aims and what are the specifications? Next one, where we have to conduct this test. Where we have to conduct this test, always short circuit test conducted on HV side and LV short circuited. LV short circuited. LV side short circuited, test conducted on HV side. Test conducted on HV side for meter's convenience for easy analysis. This is simply about the short circuit test. Now we have to conduct the test. We have to conduct the test. So conduct the test. First, wattmeter reading. Here the wattmeter reading WSC is equals to VSC ISC cos pi SC. VSC ISC cos pi SC. From this we can calculate cos pi SC. Cos pi SC is equals to WSC by VSC ISC. From this we can calculate this one. Its value around 0.5 to 0.6 lagging. 0.5 to 0.6 lagging. Short circuit power factor. Then after we can write this WSC as a ISC square into R01 or R02 with respect to primary or with respect to secondary. WSC is equals to ISC square into R01 if it is a single phase. If it is a three phase, 3 into ISC square into R01. From this we can calculate load parameters. R01 is equals to WSC by ISC square. I got R01. Next, ZSC or Z01 is equals to VSC by ISC. We can get ZSC or Z01. I have Z01 and R01. Then calculate X01. X01 is equals to square root of Z01 square minus R01 square. I have R01, Z01, X01. All the parameters, load parameters and losses. This is simply to find ZSC and ISC. From this ISC is equals to VSC by ZSC. ISC is equals to VSC by ZSC. This is simply the short circuit test of transformer. Voltage regulation, I will tell you separately voltage regulation heading with. Okay, this is simply the short circuit test of my transformer, very important. Okay, see here, so from this, the rated short circuit current is equals to, I given you formula VSC by Z01, but steady short circuit current is equals to E upon Z01. E is the HV side. I take E1 by Z01. This is steady short circuit current. For example, I want per unit steady short circuit current. Per unit steady short circuit current. Per unit current is equals to actual current by base current, right? Actual value by base value. So actual value I want per unit, but here actual value is the steady short circuit current and base value is the rated short circuit current. Actual value by base value is the per unit value. Now tell me what is answer. Actual value is E1 upon Z01 and rated current is a rated current. This can be written as E1, this can be written as 1 by IZ01 by E1. What it can be written as? This can be written as 1 upon per unit impedance. Yes or no? IZ by E, actual value by base value. So therefore per unit steady short circuit current, is equals to 1 by per unit impedance. 1 by per unit impedance. This is also very important thing. 1 by per unit impedance. This is completely about short circuit test. On this also we have a special calculations. Once see here, special calculations. Once see here and removing this. Once see here. If this is a short circuit losses, this is short circuit current. If I want copper losses at full load, then the full load current square into R01. Or if I want copper losses at off load, then off load current square into R01. Simply copper losses is equals to I square R. So from first and last, copper losses is equals to I square R. Copper losses is equals to I square R. Short circuit losses is equals to short circuit current square into R. Divide these two. R01 cancel. So finally formula very important. Copper losses to the short circuit losses is equals to I by ISC whole square. They may ask you problems on this equation. If you want to full load copper losses, you have to substitute full load current. If you want to 10% of load copper losses, you have to substitute 10% of load current. Like that, we can calculate any copper losses. This is the very important thing. Now, some special questions on short circuit test. Short circuit test conducted on a transformer. With 8 to 10% of voltage, 8 to 10% of rated voltage, and reduced frequency. This is case 1. And what is the case 2? Case 2, 8 to 10% of rated voltage and increased frequency. This is required voltage, reduced frequency, required voltage, increased frequency. Only 2 cases, no 4 cases, only 2 cases. Because this is fixed value. Don't say here increased, decreased. This is a required value. We can't say which is one this. So this is fixed. So we have to reduce once and we have to increase once. So calculate it. Short circuit test conducted on a transformer with required voltage and reduced frequency. So tell me, generally frequency reduces nothing but reactance reduces. When reactance reduces, automatically impedance decreases. When impedance decreases, the power factor is equals to R by Z. Power factor is equals to R by Z. If impedance decreases, power factor increases. If impedance decreases, power factor increases. One is completed. First one is power factor. Next one, short circuit current. Short circuit current is equals to V by Z. When impedance decreases, then short circuit current also increases. One is the power factor. Another one is the short circuit current, and next one is the short circuit losses, right? So short circuit losses, tell me, when short circuit current increases, short circuit losses also increases. When short circuit current increases, short circuit losses also increases. This is simply at this condition, power factor increases and losses increases, short circuit current also increases. Short circuit current also increases. This is simply short circuit test, special case 1. Special case 2 with increased frequency you have to do. This is simply about the short circuit test and its calculations. You have to remember this one and this one also. Per unit steady short circuit current. Steady short circuit current is equals to 1 by per unit impedance. Are you okay? Right? Thank you, sir.